Okay, refer to diagrams 3 and 4 up above. Draw the midline on each diagram. There's a formula for midline that is very simple to do. The only problem with it is it looks an awful lot like the amplitude formula. The midline is maximum plus minimum divided by 2. In other words, the midline is the average of the max and min of your wave. So let's see if we can put that to work up here. Diagram 3. They didn't label this incredibly well, did they? I'm going to have to assume that that is 2. Given that this valley goes 1 unit down, I have to assume this hill goes 1 unit up. I'm not real happy about that, especially in an example where we're supposed to be pretending we don't know where the midline is, but I don't have a lot of choice here. So my midline here is maximum plus the minimum, which is 0, divided by 2. My midline is at 1. So its equation is y equals 1. And of course, that means it looks like that. And you know you've drawn your midline well when the parts of the sinusoid that are above it and the parts that are below it are equally big and look like mirror images of each other. So let's try that again. This other wave, midline is the maximum, which seems to be 0.5, plus the minimum, which is, these people did not do a nice labeling job here, and it's making me grumpy. I guess that's got to be minus 1.5. I know it is because the normal sine wave has a minimum at -1, and this one's half a unit lower, but still they should be labeling these better for an example about midlines. Okay, so max plus min divided by 2. 0.5 plus negative 1.5 is -1. Cut that in half and you get negative 0.5. So the equation of the midline is just y equals negative 0.5. That's a horizontal line, and it ought to go something like that. Again, you can see that the hills above the midline and the valleys below the midline are equally sized. That means you probably did it right.